Hello, good morning students. Today we'll see how to write down code in a Xilinx. So on the desktop you will see the option as a Xilinx IC design suite. So first you have to select it. After that you will get a window. So there is an option as a file. So first you have to create your own project. So that's why you have to go in a new project. After that you have to assign the name to your project. So suppose I am taking here as a or22. Okay, so after that there is a next. Okay, so you will get a next window. So where you had to just make a setting for the downloading. So here you have to download your kit in a FPGA kit. So there is a family as a Spartan 3. Your device is a XC3S400. Package is a PQ208. Speed is -5. Okay, and we have to simulate our code in a iSIM simulator. And our preferred language is a VHDL. So normally this parameters you have to set at the time of downloading. Okay, but you first try to set this parameter and then go for the next. Okay, so here you will get a project details and device. After that you will get again this window. So here you have to, there is option as a new source. So first you have to go in a new source. After a new source you have to select, there are many options available, but we are writing our code in a VHDL, so that's why you have to select the VHDL module. Okay, now here this is a file name. So already you know your code is divided into three parts. One is your library, second one is your entity, and third one is your architecture. So now this file name is nothing but your entity name. So you have to take a precaution that your entity name should not start from any number, any special characters, okay, or any gate. Okay, means there are basic gates are available directly, and also for that it is not start from any number and all. So if you are taking any name gate, so you have to add some numbers there. Okay, so that's why again I am giving the name as or22. Okay, now this is the next. So after that here you will get one pointer where you have to declare your input and output ports. So now I am writing this code for a 2 input OR gate. Okay, so A is my input. So in the direction there are three options available: in, out and in, out. So first you have to select as a in, then there is a B, that is your in. Okay, and now my output is a Y, so in the port you have to select as a output port. Okay, so then you have to go next. So you can observe it here, already we have given the entity name as a or22. Now my architecture name is behavioral. So now in the architecture part you can change your modeling style. Okay, you can change the name also, and now these are the ports which we have already declared here. Okay, so this is finished. Now here you can observe it directly, your code is available here. So here are the libraries. So this by default libraries are available. So your library is IEEE library. Okay, and inside that there is package as a 1164. Okay, so directly here your entity part is ready. Now you have to go in a architecture part. So again there is a begin and end line is available. Okay, so between begin and end, simply you have to write down your code. Now my code is Y is assigned as A or B. All logical operators are available here, all logic gates are available here. So directly you can write it by using OR. So this code is this is your data flow modeling style I have used here. But please take one precaution here. Suppose I have write here behavioral and I am using a modeling style as a data flow, again it will work, because architecture name you can give anyone. Okay, any architecture name you can give it here. Okay, so actually my code is by using data flow, but here I have written as a behavioral, but you can keep as it is. Okay, so now my code is ready. So first I have to save it. Okay, after that here are the, on the left side you can see the two options. There is the implementation and the simulation. So first you have to go in the implementation. Okay, so this is my code or22.vhd. Okay, so now your next step is what? First you have to check whether there are some errors or not. Okay, so that's why you have to go in a simulation. So after a simulation, you have to click on your code name. Then you will get a two option. One is your check syntax and the second one is your simulate behavioral model. So first you have to do the check syntax. Okay, so in the below window you will get the line as process behavioral check syntax completed successfully. Okay, so your code is correct. Okay, there are no errors. So after that you have to go for the simulator. Okay. Okay, so here just I write down my top model as a 22. Okay, this is or 22. Okay, now I have to go for the simulate. So here directly you can make a double click or you can go with run option. Okay, simulate. So here you will get a simulation window. So already I have taken A, B as my input and Y is my output. So here you have to verify the truth table of your OR gate. So first you have to go in a first variable, that is A. Just make a right click. Here you will get an option as a force constant. Okay, so in the force constant there is a signal name. So that is a by default. Okay, value is a radix, because there is only ones and zeros. Then next is there is a force to value. So where you can just give the value as a 0 or 1. Okay, after that you can go with apply. Okay. Okay, the same procedure you have to do it for B, that is for constant. Now I am taking 1 here for the B. Now my inputs are 0 and 1. Okay, so after that here is the run option. There are two triangles, so where X is written, that option you have to do it. So you will get the answer. So you can check this window now. So there is A is 0, B is 1 and Y is 1. Okay, so here is one cursor is available. By using this you can check your output. Now this zeros and ones you can see in the form of your waveform. So that's why 0 at a ground line but 1 is at a high level. Okay, so suppose again B input I change it here as a 0. So if my input is 0, both inputs are 0, 0 and I will go for a run option. So here you will make a change. Okay, just see. I can move the cursor here. If I put my cursor here, I can see my input A is 0, B is 1. But I move this cursor, what will happen? A is 0, B is 0 and your Y is also 0. Okay, so according to that you can verify your truth table. Here I have applied the two values. Okay, that is 0, 0 and 0, 1, but you can try it for the 1, 1 and 1, 0. Okay, so means as per this you can verify your truth table. Hope students you understood this. Okay, this is a simple code for the OR gate. You just go through it. Okay, and after that we'll go again for the next code. Okay, we'll stop it here. Thank you.